How to create and install SSH keys from the Linux shell. Take cybersecurity seriously and use SSH keys to access remote logins. They're a more secure way to connect than passwords. We show you how to generate, install, and use SSH keys in Linux. Secure Shell, SSH, is the encrypted protocol used to log into user accounts on remote Linux or Unix-like computers. Typically, such user accounts are secured using passwords. When you log into a remote computer, you must provide the username and password for the account you are logging into. Passwords are the most common means of securing access to computing resources. Despite this, password-based security does have its flaws. People choose weak passwords, share passwords, use the same password on multiple systems, and so on. SSH keys are created and used in pairs. The two keys are linked and cryptographically secure. One is your public key, and the other is your private key. They are tied to your user account. If multiple users on a single computer use SSH keys, they will each receive their own pair of keys. Your private key is installed in your home folder, usually, and the public key is installed on the remote computer, or computers, that you will need to access. Your private key must be kept safe. If it is accessible to others, you are in the same position as if they had discovered your password. A sensible, and highly recommended, precaution is for your private key to be encrypted on your computer with a robust passphrase. The public key can be shared freely without any compromise to your security. It is not possible to determine what the private key is from an examination of the public key. The private key can encrypt messages that only the private key can decrypt. When you make a connection request, the remote computer uses its copy of your public key to create an encrypted message. The message contains a session ID and other metadata. Only the computer in possession of the private key, your computer, can decrypt this message. Your computer accesses your private key and decrypts the message. It then sends its own encrypted message back to the remote computer. Amongst other things, this encrypted message contains the session ID that was received from the remote computer. The remote computer now knows that you must be who you say you are because only your private key could extract the session ID from the message it sent to your computer. Make sure you can remotely connect to and log into the remote computer. This proves that your username and password have a valid account set up on the remote computer and that your credentials are correct. Don't try to do anything with SSH keys until you have verified you can use SSH with passwords to connect to the target computer. In this example, a person with a user account called Dave is logged into a computer called HowToGeek. They are going to connect to another computer called Sulaco. They are asked for their password. They enter it, and they are connected to Sulaco. Their command line prompt changes to confirm this. These instructions were tested on Ubuntu, Fedora, and Manjaro distributions of Linux. In all cases the process was identical, and there was no need to install any new software on any of the test machines. The generation process starts. You will be asked where you wish your SSH keys to be stored. Press the Enter key to accept the default location. The permissions on the folder will secure it for your use only. You will now be asked for a passphrase. We strongly advise you to enter a passphrase here, and remember what it is. You can press Enter to have no passphrase, but this is not a good idea. A passphrase made up of 3 or 4 unconnected words, strung together, will make a very robust passphrase. You will be asked to enter the same passphrase once more to verify that you have typed what you thought you had typed. You can ignore the random art that is displayed. Some remote computers might show you their random art each time you connect. The idea is that you will recognize if the random art changes, and be suspicious of the connection because it means the SSH keys for that server have been altered. We need to install your public key on Sulaco, the remote computer, so that it knows that the public key belongs to you. We do this using the SSH copy it command. This command makes a connection to the remote computer like the regular SSH command. But instead of allowing you to log in, it transfers the public SSH key. Although you are not logging into the remote computer, you must still authenticate using a password. The remote computer must identify which user account the new SSH key belongs to. Note that the password you must provide here is the password for the user account you are logging into. This is not the passphrase you have just created. You are returned to the command prompt of your computer. You are not left connected to the remote computer, because the process of connection will require access to your private key, and because you safeguarded your SSH keys behind a passphrase. You'll need to provide your passphrase so that the connection can proceed. Once you've entered your passphrase in a terminal session, you will not have to enter it again for as long as you have that terminal window open. You can connect and disconnect from as many remote sessions as you like without entering your passphrase again. You could tick the checkbox for the automatically unlock this key whenever I'm logged in option, but it will reduce your security. If you leave your computer unattended, anyone can make connections to the remote computers that have your public key. To verify the process once more end-to-end, disconnect with the exit command and reconnect to the remote computer from the same terminal window. Cybersecurity experts talk about a thing called security friction. That's the minor pain that you need to put up with to get the gain of additional security. There's usually some extra step or two required to adopt a more secure method of working. And most people don't like it. They actually prefer lower security and the lack of friction. That's human nature. Text source, howtogeek.com.